Copy 724, right. Center maintain 2000.
Center maintain 2074.
Comment 504 to center maintain 3000.
3000, comment 504.
In this video, we're gonna be continue covering and we'll try to finish everything related to nature of the atmosphere. So this is the part 3 for this particular section. The first thing we want to cover is we're talking about the icing and the frost. So is the frost considered hazardous to the flight? So the answer is yes, because while the frost does not change the basic aerodynamic shapes of the wing, but the roughness of the surface spoils the smooth flow of the air, and that would actually it will slow down the airflow. So the things which you can expect is the aircraft won't become airborne at the normal takeoff speed, and if you are because it's not gonna give you a lot of the uplift, so you can expect stalling while you are on airborne. Okay, now we're gonna be talking about the thunderstorms. So, what are the factors which must be present for the thunderstorm to form, right? So, the first factor is that the sufficient water vapor. So, we need to have sufficient water vapor for that. The second one is the unstable lapse rate. Then we also need to have the lifting force, right? The upward boost, which is basically gonna take all the clouds up and down. Upward boost, right? So that is the force which is gonna need it for in order to basically start moving the storm. Now we're gonna be covering, we were talking about the thunderstorms, right? So the 3 stages of thunderstorm. Okay, the first stage is called Cumulus. Let me just write down the names first. The second one is mature, and the third one is dissipating. So again, very intuitive. Cumulus is gonna be when the updrafts that causes the raindrops to increase in size. So basically, it is accumulating. And mature state is so it starts raining. It falls through it starts raining on the earth's surface, right? And lightning could happen and that kind of stuff. And the dissipating is where it is the downdraft and the rain begins to dissipate. These are the 3 stages. Okay, now we're going to be talking about the temperature inversion. We did touch it a little bit before. So what is it? What is the temperature inversion? So it is the increase in temperature with height. As you may know that increase in temperature in the normal circumstances is gonna be decreasing the temperature. But in this rare case, the temperature is gonna be be increasing with the altitude. So yeah, that's basically the definition of it. Yeah. Okay. So state two basic ways that fog may form. So you can say what are the causes of the fog. One is if the cooling air to the dew point. So the air is cool until you hit the dew point. That is one. The second one is adding moisture to the air near the ground. So these two things, if the air is cooled enough that it hits the dew point, you're gonna see the fog, or there is enough moisture like added to the air near the ground, then you're gonna be seeing the fog. Okay. What are the different types of fog? Fog types, right? So the first one is the radiation fog. Then we have advection, upslope, then frontal fog, also known as the precipitation induced fog, and then the steam fog. Even if you know, like radiation fog, uh, frontal fog because of the different fronts, upslope fog because you are somewhere close to an upslope like mountainous areas. So if even if you can name a couple of them, should be enough, should be good enough for the test. Okay, so we're going to be talking about the radiation fog, like what causes the radiation fog to form. What is it? What causes the radiation fog to form? So the ground cools the adjacent air to the dew point uh, on the calm, like clear nights. So that actually causes the radiation fog. So the ground is gonna become it's, let's say, if it is winter or it is cold enough that it cools the adjacent air, like how much it should cool it up to the dew point, then that is called the radiation fog. Then what is the advection fog? So it results from the transport of the warm humid air over a cold surface. So if you have air, it is like the and it's moving around, right? And it is warm and humid, and it hits the cold surface. That would be called the fog created by that is called the advection fog. Normally, you will find it in the coastal areas, okay, uh, and like yeah, the other difference is like that radiation fog is normally occurs at night, whereas the advection fog is like day or night. It could happen on different kind of terrains, and it can happen like um, it can happen on the like even it can happen on day or night. Now the upslope fog. So it forms as a result of moist, stable air being cooled uh, adiabatically as it moves upslope, moves upsloping terrains. So once the upslope wind ceases, the fog just disappears. So as I said, it has to do with the terrain, like it. It is normally very dense, and it becomes more visible in the higher altitudes. So these are the only three which we wanted to go in the little bit more detail. Okay, now we're going to be talking about another thing which we definitely should know. It's called the wind shear. So what is it? It's defined as the rate of change of wind velocity. It could be like the direction, it could be the speed per unit distance, right? So the rate of change of the wind velocity, both the direction and the speed per distance, like per unit distance. And it could be vertical wind shear and it could be horizontal wind shear. And it can occur at any level in the atmosphere. And remember that three areas, like it can occur at any level in the atmosphere, but three areas are of special concern, which I'm gonna point out. Like one is like where we have the low level temperature inversion. Temperature inversion, as we talked about it, that it's a behavior where by like increasing in the altitude instead of decreasing the temperature starts increasing. That's the temperature inversion. So low level, if at the not like low level temperature inversion, uh, you will uh, you need to be careful about the wind shear, right? Okay, the second one which can be a concern is like in the frontal zone, like the wind shear in a like when there are fronts going on, or you can say the thunderstorms are there. Plus you have this wind shear that can be a concern. And the third one is the clear air turbulence, also known as CAT. And this is like at high levels associated with the jet stream or a strong circulation. So these are the things which, if you are in this one, you need to be aware if there is any wind shear going on, which is basically the rate of change of the wind velocity. So we covered 12 here. 10 questions here. Okay. So again, talking about a little bit more about the wind shear, like why is it's a concern for the when the pilots are flying the plane? Why is it of concern? So it is because it is unexpected change in the wind speed, and the direction can be potentially very hazardous to aircraft operations at lower altitude, on approach, or depending on the or even when departing from the airport. This can be like because if there is a lot of rate of change in the wind speed, the behavior is going to be very unexpected. So we definitely need to know about the wind shear. Okay, and the last thing we wanted to cover is like uh, so if you want to know about the wind shear, right, what kind of weather information you're gonna be weather info for wind shear, like what would you look for in order to know if there is any wind shear? So I'm just gonna call it out. One is the terminal forecast. then meters, then the segments, then LL was, and I will explain it a little bit in a little bit. PI rep. Okay, so terminal forecast, like it could any mention of the low level wind shear or the possibility of severe thunderstorms, all those things, you can find them in the terminal forecast, right? They like when you are reading the forecast or when you are listening to it, it may mention that, like meters. So it inspects for any indication of the thunderstorms, rain showers, dust, those kind of things. Additional signs such as warming trends, gusty winds, and also the type of the cloud should be noted in the meters. Okay, and then the segments is like when these are basically the severe weather watch reports. So, like if you find any severe weather watch and anything in the severe weather watch reports, it could be a source for the information that there is a wind shear or microburst, right? And then LLWAS, also known as the low level wind shear alert system, LLWAS. So this is like these they have reports, and they are installed at like a lot of airports in the US, and they are basically designed to detect the wind shifts and the wind patterns. And the PIREPS reports of sudden air speed changes on departure, approach, and landing, uh, that can also be found in the PIREPS. So that these you should be looking, like you should be reading, and you should listen to these weather information in order to either know, or at least like you would have a little bit of information about that whether or not you should expect the wind shears.